Hello everyone. Welcome to part 2 of the yogurt production example. In this video, I will demonstrate how to use bills of materials, or BOMs, to define which raw materials and intermediates are required to produce a given product SKU. The BOMs can then be linked to recipe streams to account for consumption of the materials. This case also describes how to specify variable operation durations based on SKU types, such as product type, product size, etc. SKUs may differ in multiple characteristics. For instance, in addition to differing in container size, yogurt products may also differ in flavor. Let us consider 3 different yogurt flavors: banana, peach, and strawberry. The combination of 3 different flavors with 3 different cup sizes creates 9 different product SKUs. Flavoring is accomplished by feeding the corresponding fruit puree through an inline mixer in the filler feed line. The fruit to total yogurt mass ratio is 1:10. Raw materials such as milk used to make the yogurt and the fruit purees used for flavoring can also be considered as SKUs. Material requirements for the production of a final product are represented with what is called a bill of materials, or BOM. A tree-like representation of a BOM is shown here for the banana-flavored 200-gram product. To represent the expanded list of 9 product SKUs, as well as their BOMs, the following steps were performed. First, the new product SKUs were created using the same steps described previously in the Case B example. This resulted in the 9 new SKUs shown here. Then, 4 additional SKUs were created to represent milk, banana puree, peach puree, and strawberry puree. Note that each of the product SKUs was also assigned a BOM. The BOM for the banana 200-gram SKU is shown here. In this tab, the materials required to produce a given quantity of banana 200-gram SKU are declared. The left-hand side list shows the available materials. These can be either standard materials declared in the Materials view of the Explorer or raw material SKUs. Materials may be added to the BOM by selecting them from the list on the left and clicking the Add SKU or Material button here. Materials may be removed from the BOM by selecting them from the table and clicking the Remove button. Notice that the BOM also allows you to define the amount of each material in the SKU. In this case, a single entity, or cup, of 200-gram banana SKU requires 180 grams of milk and 20 grams of banana puree. Notice that the production amount basis can be changed by the user, in which case the amounts in the BOM should be scaled accordingly. Unlike the 9 product SKUs, the milk and fruit puree SKUs were classified as raw materials, and their amounts are measured on a mass basis. Furthermore, these 4 SKUs were all assigned to relevant storage units. These storage units were defined prior to defining the new SKUs. The storage unit definition was done through the equipment node of the yogurt plant facility in the same manner described earlier. After the relevant raw material SKUs have been defined, the consumption of these raw materials can be linked with existing or new recipe streams or operations using the Assign SKU Production Recipe dialog. This process will be explained in greater detail later in this video. However, before we revisit the SKU Recipe Association dialog, the master recipe should be modified to allow the definition of operations whose duration is type and size based, and also account for the mass balance changes caused by the introduction of the flavoring material. To define the new SKU types, first select Options Recipe SKU Types from the main menu. In this dialog, new SKU types can be defined for a given classification category, such as product type, by clicking the Add New Type button. As you can see, 3 product types, banana, peach, and strawberry, have already been defined for this project. In case B, the packing size classification was used to differentiate the filling rates among SKUs. However, the cleaning time for the filler was assumed to be a constant 60 minutes. In contrast, in case C, we will assume that the filler needs more thorough cleaning when switching from strawberry yogurt to peach yogurt, or from either of those products to banana yogurt. We will also utilize a packing size based filler changeover for the time needed to reassemble the filler when the cup size is to be changed. To represent the durations of these sequence-dependent cleaning and cup size change operations, special changeover matrices, or COMs, were defined. If you are unfamiliar with SchedulePro's changeover matrix functionality, please refer to the README file for this example and/or the SchedulePro manual for a thorough explanation. Creation of COMs will not be explained here. Within this file, 2 COMs have been defined: a product change COM that is used to determine cleaning times when switching between products, and a size change COM that is used to determine the duration of the changeover when switching cup sizes. Notice that the product change COM applies different durations when switching between different products. For instance, when switching from strawberry to banana, a 90-minute changeover is used, but when switching from strawberry to peach, a 75-minute changeover is used. At this point, we must revisit the recipe and change the duration of the CIP operation of filling so that it makes use of the product change COM. We will also introduce a pre-processing operation to incorporate the size change COM into the recipe. To make these changes, I will first select the stirred yogurt recipe in the Explorer tree, select the fill procedure, select the CIP operation, and click the Edit button. Moving to the Duration tab, I will select the Duration Based on Main Equipment Changeover Matrix option. In this case, the desired changeover matrix is already selected, and the transition policy is correct as well. These settings specify that the duration of this CIP operation will be based on the type of product that utilizes the filler next, with the time values coming from the product change matrix. Note that the recipe itself does not have a product type classification. This will be determined by the SKU that the recipe is called upon to serve when a new campaign is scheduled. At this point, we need to introduce a pre-filling operation for size changeovers. To do this, I will select the filling operation and click the Insert New Operation Before Selected button. I will call the new operation Size CO. Then I will select it and edit its properties. On the General tab, I will specify that this operation is a changeover type operation. As before, the duration will be based on a COM, but this time the size change COM is chosen and the State Transition with respect to task before option is selected. This will ensure that the duration of this operation is dependent upon what cup size the previous filling operation was handling. We also need to visit the Scheduling tab of this new operation to specify that it should be completed before the filling begins. To properly account for this, the operation should be scheduled with respect to another operation in this procedure, the filling operation should be chosen, and the size CO operation should be set to finish when the filling operation begins. Another change related to the filling operation should now be made to the structure of the recipe. In the original plain yogurt recipe, we assumed that all procedures in the recipe would handle the same amount of material, which was equal to the recipe batch size. With the introduction of flavoring, this is no longer the case. Now, 10% of the final yogurt amount is attributed to the flavoring added at filling time, which means the remaining 90% is milk. Therefore, upstream equipment, such as the pasteurizer and the cooler, now process only 90% of the batch size. This affects the processing times for the receive pasteurized milk and cooling operations. To incorporate these differences, it is necessary to revisit the ferment procedure in the stirred yogurt recipe and edit the receive pasteurized milk operation. Moving to the Duration tab, I will click the Setup button in order to edit the rate-based duration of this operation. Here, the amount processed should be changed from 12 to 10.8 metric tons, which is equivalent to 90% of the 12 metric ton final batch size. The same process should be repeated for the cooling operation in procedure Cool. Note that you can review all amount-related specifications in a recipe by selecting the recipe and clicking the Edit Streams button in the Recipe view. Any procedure, operation, or stream-related amounts that have been defined for the recipe are shown in this dialog and color-coded based on their scaling behavior, i.e., how these amounts scale if the recipe itself is scaled. Streams can also be edited directly through this dialog. In our case, there are no streams, but the amounts considered for the calculation of the receive pasteurized milk, cooling, and filling operation durations can be seen. For a batch size of 12 metric tons of final product, the pasteurize and cooling operations will process 90% of that quantity as milk and plain yogurt, while the filling operation will process the full amount because of the addition of the flavoring material. We are now in a position to revisit the SKU recipe linking. To view or edit the recipe links for a given SKU, first select the SKU and then click the Assign SKU Production Recipe button. As with Case B, the production of each of the product SKUs in Case C has been associated with the filling operation in the fill procedure in the stirred yogurt recipe. In addition, each of the 200-gram SKUs were given a nominal batch amount of 60,000 entities, 60,000 cups in this case. Unlike Case B, a new specification should be made within the SKU classification section. Each product SKU should have a specific product type assigned to it. This assignment has already been made for all the product SKUs in this particular file. In addition to specifying the product type for product SKUs, the BOM specifications for each product SKU should be checked. The BOM for an SKU is specified on its Feed tab. In this tab, there is a pre-filled table with the materials required to produce the nominal amount for banana 200-gram SKU. The SKUs needed and the corresponding amounts have automatically been set based on the SKU's BOM structure defined earlier. What we may need to change is the stream assignment and the corresponding operation that consumes each raw material. To do that, select the corresponding line from the table and click on the Edit Feed SKU Material Stream button. For the milk SKU, the operation which uses this material is the Receive Pasteurized Milk operation in the ferment procedure, as shown here. This specification could be changed by selecting different procedures and operations in the drop-down menu if desired. This process should be followed for all materials in the BOM to ensure all materials are consumed at the appropriate times in the batch. Also notice that in this case we have used a virtual stream that is independent from the recipe. The consumed amount here is preset based on the SKU's BOM. However, it is possible to overwrite these amounts if desired, which would then overwrite the amounts initially defined within the BOM. The process of assigning receiving operations and verifying feed stream amounts should be followed for each product or intermediate which has been assigned a BOM. The other product SKUs listed in this table have all been assigned appropriate feed streams already. Note that it is possible to generate a block diagram for the assigned recipe, transformed to serve a specific SKU, by selecting the SKU of interest and clicking this button. Here is the recipe block diagram for banana 200 gram SKU. Compared to previous displays of the recipe, the following changes have been introduced. The durations of the receive pasteurized milk and cooling operations and their slave operations have decreased because they receive only 90% of the nominal batch size. In addition, new streams, colored black, have appeared based on the SKU's BOM requirements. At this point, we can schedule a series of campaigns representing different flavors and container sizes based upon our single recipe. This is done by choosing the Associate with SKU option for each new campaign and selecting the desired SKU for each campaign from the drop-down menu. I will create 3 6-batch campaigns of different products now. The strawberry, peach, and banana campaigns are shown in red, orange, and yellow respectively. As before, the cleaning operations within this EOC are shown in white. Notice that since there is a single product change after each campaign, the product change COM creates 3 cleaning operations for the filler, one at the end of each campaign. Furthermore, the durations of the filler's cleaning operations differ from one another based on the differing values set within the product change COM. Likewise, because each campaign uses different sized cups, the size change COM creates 3 size changeover operations for the filler, shown in light blue. With this setup, the 18-batch campaign is scheduled to finish during the night of January 22nd. The effect of campaign size on the associated size changeovers can be seen clearly if instead of several large campaigns, we schedule many smaller campaigns. For instance, this file represents the production of all 9 product SKUs, each of which is produced by a 2-batch campaign. Notice that even though the total number of batches is the same as the previous file, i.e. 18 batches, the make span for this file is longer because there are more size changes. Therefore, instead of completing production during the night of January 22nd, the schedule isn't complete until the morning of January 23rd. An even greater impact from cleaning and size changeovers can be seen if the campaign order is randomized, resulting in additional switches between products. This scenario is displayed here, where there are many additional cleaning operations required in the filler since there is so much product switching. In this case, the 18-batch production plan is not complete until roughly 10 a.m. on January 23rd, rather than finishing at roughly 7 a.m. on January 23rd in the previous case. These cases illustrate how frequent product switches, in the spirit of just-in-time manufacturing, may significantly reduce the capacity of a production line because considerable time is wasted for cleaning and changeover activities. Simulations such as these allow you to weigh the pros and cons of these types of plant management and inventory reduction strategies.